Have you ever wondered what powers the digital world? What's the magic behind the binary system that forms the very backbone of our computers and smartphones? Of course you have. So today we're going to unravel one of the key components of digital logic design, the D flip-flop circuit. At its core, the D flip-flop circuit is a marvel of engineering simplicity. It's a type of flip-flop, a fundamental building block of digital electronics, which is used to store one bit or binary digit of data. The D in D flip-flop stands for data. This might sound straightforward, but the way it operates can be quite fascinating. The D flip-flop circuit essentially has two inputs and two outputs. The inputs are usually termed as D, which stands for data, and CLK, or clock. The outputs, on the other hand, are Q and not Q. Here's how they function together. The D input is where we feed our data, which can be either a 0 or a 1. The CLK input is a bit special. It acts like a trigger. When the clock input changes from a 0 to a 1, which we call a positive edge, the D flip-flop takes a snapshot of the data input. Now, the magic happens. Whatever data was on the D input at the moment of the positive edge gets transferred to the Q output. The not Q output, as the name suggests, is simply the inverse of Q. If Q is a 1, not Q is a 0, and vice versa. So in essence, the D flip-flop circuit is a kind of memory. It remembers the state of the D input at the moment of the positive edge of the clock and keeps that memory until the next positive edge arrives. What's so special about this? Well, imagine a chain of D flip-flops, all connected in a row. Each flip-flop stores a bit of data, and with each clock pulse, the data moves down the line. This is how shift registers work, a key component in many digital systems. To summarize, the D flip-flop circuit is a simple yet powerful tool in digital logic design. It has two inputs, D for data and CLK for clock, and two outputs, Q and not Q. The circuit stores the state of the D input at the moment of the positive edge of the clock and keeps that memory until the next positive edge. This makes it a fundamental building block for storing and transferring data in digital systems. So the next time you use your smartphone or laptop, remember the humble D flip-flop. It's one of the unsung heroes of the digital world, working tirelessly behind the scenes to make our digital lives possible.